Okay, I'm going to do a problem that I actually got from this website here. What I want to prove is that this language, a to the 3, b to the m, c to the m minus 3. Oh. Okay, I'm going to do a problem that I actually got from this URL. There's some slides on the pumping lemma. I was looking for some problems, and this one had a nice one. And the problem that I want to prove is that a to the 3, b to the n, c to the n minus 3, such that n is greater than 3 is not regular. So this is a string that starts with 3 a's. Well, this is the language of strings. Starts with 3 a's, then has as many b's as you want as long as it's more than 3, and then 3 fewer c's, right? So, for example, here's a string that's in there. Let's put this in the corner here. Let's see, we have to have 3 A's, then as many B's as we want. Let's give it 4, and then a C, right? Or we could have 3 A's and 3, 4, 5, 6, and 3 C's, if I can cram that in there. So those are some strings in my language. All right, so let's do the proof, and I'm going to do the proof using my pumping outline of just how to do this. So let's say, let L equal, and we're going to fill in the language again, a to the 3, b to the n, c to the n minus 3, such that n is greater than 3. And let's assume that L is regular. Now, I'm a little bit worried I'm going to run out of space on this page, so I'm going to be cramming stuff in as small as I can. Let's let M be the number from the pumping lemma. Okay. Now, we've got to pick some string for S. And it has to be at least m characters long. So let's let S equal, a reasonable first guess is a to the 3, b to the m, c to the m minus 3, right? Because that's definitely at least m characters long. And since S is in my language, right, and the length of S is greater than or equal to m, the pumping lemma must apply. Specifically, we know that S can be split into X, Y, Z, a sequence of 3 strings squished together, concatenated together, where Y does not equal the empty string, and the length of X and Y together combined is less than or equal to M. Okay, so now we need to think about what Y looks like. And because we have this really weird language, we end up with really weird strings. We know that Y has to be, let's see, we know that Y has to occur within the first m characters of S, right? So that gives us 3 options for Y. So Y could equal one of 3 things. All right. So what we're going to do is we're going to prove that no matter what Y is, whether it's option 1, option 2, or option 3, no matter what we do, we always end up with a contradiction. Okay? So the first option for Y is that Y is just A's, right? That would mean Y equals, let's see, A to the K, where, well, we have to have at least one of them, right? Because Y can't be empty. We know Y is not lambda. So K is greater than or equal to 1, and it has to be less than or equal to 3 because we said, well, y is just a's, so there only are 3 a's. Okay. The second option is y is some a's and some b's, right? In that case, y is going to equal a to the k, b to the, I got to pick another letter, let's do b to the x, right? And under those circumstances, let's see, I guess the a part could still be between 1 and 3, I mean the k part, yeah, the a part. And x, well, let's see, we can't have more than m letters, so I guess x has to be less than or equal to m minus 3. Sorry about going over that line there. And x has to be greater than or equal to 1, because we said there's some b's in there, right? And the last case is where y is just b's, in which case y equals b to some number x. I could have said b to the k too, but we'll just stick with the x. And in that case, x has to be at least 1 and could be as many as m. All right. So what we're going to do is we're going to show that for number 1, for number 2, and number 3, no matter which option we pick, we lose. We always hit a contradiction, and therefore our assumption must be false, right? Because we assumed L was regular at the beginning. That's the only assumption we made. So if y is just a's, y is a to the k, then what's x? Well, x might be empty, or it might have a's in it, right? X comes before y, so if y is all a's, x has to have a's too. So I need another letter. Let's make, oh dear, that was really horrible to make that an x, wasn't it? So let's make, let's see, what can I do to fix this? Let's make all these x's little q's. All right. I think I got them all. All right. Okay, sorry about that. So the x piece is going to be just a's, and now I need another letter that I haven't messed up with. Let's see. Let's try a to the h. And how many a's can we have for x? Well, I guess h could equal 0, right? Because nobody says x can't be lambda. And h has to be less than or equal to 2 because at least one of those a's had to go to y. And let's see, z over here is going to be maybe some a's, and definitely all the b's and all the c's. So z is going to be, and that's an h, by the way. My h's are going to look like n's, which is not good. Z is going to be however many a's are left over, so a to the 3 minus k minus h. And then however many b's we have, b to the m and c to the m minus 3. Okay. So we know what x, y, and z are in this case when y is just a's. So let's see what happens with x, y, y, z. Right? By the pumping lemma, x, y, y, z is going to be an element of my language, right? That's what the pumping lemma says. By the way, before I forget to say it, this is cramped because I only have one piece of paper to show you this pen cast on. If you're really writing this, leave some white space so it's more readable. Okay, so by the pumping lemma, x, y, y, z has to be an L. So what is x, y, y, z? Well, x, y, y, z is a to the h, that's x. Y is a to the k, and then we have another a to the k. And then z is a to the 3 minus k minus h, b to the m, c to the m minus 3. So that's my x, y, y, z, right? X, y, y, z equals this thing. And let's push that through a little bit. That equals a to the h plus k plus 3 minus k minus h, b to the m, c to the m minus 3. So that simplifies to a to the, let's see, one of the k's go away, one of the h's goes away. So we end up with a to the 3 plus k, right? Followed by b to the m, c to the m minus 3. Now we know from up here that k isn't 0, right? K has to have something in it. So that means that a to the 3 plus k, b to the m, c to the m minus 3 is not in my language, right? So that means that x, y, y, z isn't in my language. So I have a contradiction. Now this contradiction is only if I say that y is just a's. So it's possible that maybe I screwed up. Maybe y is going to be a's and b's. So let's follow this path and see if that's true. So if y is made up of a's and b's, then we figured out what y is. Let's figure out what x is. X is still going to be, let's see, x is going to have to just have a's in it because the y has an a in it. So x is either going to have 0 or a couple of a's. So x is going to equal, have I used h yet? I don't think so. X is just going to be a's, where 0 is less than or equal to h is less than or equal to 2 again, because we have at least one of those a's is in y, so x can only have at most 2. Z is everybody else. In this case, we've got some b's in y, so z is going to equal b to the m minus q, c to the m minus 3. Cool. So again, same logic by the pumping lemma. I'm just going to write PL here. X, Y, Y, Z is an element of L. Okay. And X, Y, Y, Z, what does that equal? That equals X is A to the H. Y is A to the K, B to the Q. And then we have another one of them, A to the K, B to the Q. And then we have Z, which is B to the M minus Q. Sorry, I'm squishing this here. C to the M minus 3. Of course, if you were writing this out for a real proof for class, you'd write it neatly. Okay, well, check this out. We've got X, Y, Y, Z is A to the H plus K, B to the Q, A to the K, B to the Q. Oh, B to the Q plus M minus Q, so I guess that's just B to the M. C to the M minus 3. Well, that's not in my language, is it? Right? Because I've got an A and then I've got some A's, some B's, and then more A's and B's. That's not in my language. So X, Y, Y, Z is not in my language, so I've got another contradiction. All right, last chance. It's possible that Y is just B's, right? If Y is just B's, then we said Y takes the form B to the Q, where Q is between 1 and M. So that means that X is going to be A's and maybe some B's. So X is going to be all the A's. And then M minus Q B's. And then, oops, that should be a C. C to the M minus 3. All the rest of the C's. Oh, dear. Forget that. Goodbye. X is just everything up to Y, right? So X is going to be A to the 3. And then maybe B to something else. What letter haven't I used yet? Let's use a... let's use B to the R. Okay. So X is A to the 3, B to the R, where R is going to be definitely less than M and greater than or equal to 0. And Z is going to be some B's maybe, plus all the C's. So Z is going to be B to the M minus R, followed by C to the M minus 3. Oh, B to the M minus R minus Q, because we've got to get rid of all those B's that were in Y, too. Okay, so let's figure out what X, Y, Y, Z equals. X, Y, Y, Z equals, I don't have much space here, do I? Well, x is a to the 3, b to the r. Y is b to the q, but I got two of them now. Z is b to the m minus r minus q, and then my c to the m minus 3. So let's simplify that. We got my a to the 3, and how many b's do we have? Well, we have an r here and another one, so we end up to b to the q plus m, c to the m minus 3. But we know that q is greater than 0. Right? Q has to be greater than 0. We said that here because y has to have something in it. Y can't be lambda. But if q is greater than 0, then x, y, y, z is not in my language. So we have a contradiction. So check out what we've got. If y is just a's, we have a contradiction. If y is a mixture of a's and b's, we have a contradiction. If y is just b's, we have a contradiction, right? So, no matter what form y takes, x, y, y, z is not an element of L. And so that's a big contradiction, right? Thus, our assumption must not be true. Thus, L is not regular. QED.